This is Mrs. Haslauer's video on dilations. It's brand new to today's video, so make sure you're paying close attention. What you need to know by the end of the video is what operation is associated with a dilation and how you identify whether the object is going to get bigger or smaller. You might be a little bit confused by that because up to this point, we've done their translation and our reflection where the objects remained congruent or the same thing. But today we're going to learn how to make it bigger or smaller, which is going to result in similar figures. They're going to be quite a bit alike, but they're not going to be exactly the same. Here's an example of a dilation. You take whatever your original object is. You're going to plot your vertices and connect the points. Now you're going to learn how to make an object bigger or smaller. What I need you to realize though is that the object is still the same compared to the image. It's still the same thing. It's still the same shape. Only if you were on a computer, it'd be like copy pasting and then either dragging the corner out to make it bigger or dragging the corner in to make it smaller. All the angles are still the same. What changes is the side length, but all the sides are changed by the same number. So they're in proportion. Very important. If your sides are not proportionate to each other, then you end up with a completely different shape and it's not a dilation. So take out your note sheet and let's get started. A dilation is a process of either enlarging or reducing an image, making it bigger or making it smaller. That's why I have a picture of an eye over here. If you've been to the eye doctor lately, you may have had your pupils enlarged. And what the doctor does is they put a solution in to make it bigger so that then they can see in your eye and check it out. That's what we're going to do here, but with shapes on our X and Y graph. The ratio of the new image to the original is called the scale factor. Very important. We need to understand that. The scale factor of a dilation tells us what to multiply by. What to multiply the X and Y value by. So we're multiplying with the dilation. That's what's going to make our shape either bigger or smaller. If you add or subtract numbers, that's our translation and moving it left, right, and up and down. When you're multiplying, you're going to result in a bigger or a smaller shape. The way you tell if you're going to get a bigger or smaller is by what number you're using. If your scale factor is greater than 1, your object will enlarge. It's going to get a lot bigger. We're going to see that in example number 1. The scale factor is between 0 and 1, or a fraction, the object will reduce or get smaller. That's what we're going to see in example number 2. So the best way to understand what I'm talking about is just to practice. For the first one, we're going to dilate the object by a scale of 2, or double it. We're going to make it twice as big. Another way of telling you to dilate something by 2 is to use k equals 2. K is identifying that it's a scale factor. Just like we've been doing for the last week, you're going to start by plotting your points. 1, 2, 3, 4, 1, 2, 3. Please be careful. Some of us are still making, mistakes when we're plotting because we go too fast. It's easy to do. Be careful. B is a little bit challenging because it has a 0 in there. Remember to always start at the origin. We're going to walk to -2 and then not go up or down at all. So there's our value for B right there. And then C is -3, +5. There's 3 vertices, so we end up with a triangle. Please connect the points with a straight edge. You don't need a ruler, but a straight edge will give you a pretty graph. Now the question is, how do we dilate it by a scale of 2? It really just means take your original coordinates and multiply the X and the Y by 2. What that looks like is this. A prime. My original coordinate is 4, 3. I don't want to go and graph 4, 3 again because that'll be A. What you're going to do is multiply both of those values by your scale factor, which in this case is 2, which gives me my new A prime value of 8, 6. B prime was -2, 0. I multiply both by my scale factor of 2, which gives me -4, 0. And C prime was -3, 5. that new coordinate is -6, +10. Showing your work is great, but these are the coordinates right here that we're actually going to plot. So I'm going to change my color quick, and I'm going to start graphing. Start at 0, 0. We're going to 8, 5, 6, 7, 8, and going up to 6. There's A prime. Already, we're getting bigger. Start at the origin. Walk to -4. Do not go up or down at all. There's B prime. And C prime, walk to -6, and then climb all the way up to 10. There's my C prime. Use your straight edge. Connect your vertices. And we have our triangle. Now, it's very important for you guys to understand that these two shapes are no longer congruent. Congruent means equal, means the exact same thing. These are not congruent. The side lengths are twice as long. But they may not be congruent, but they are similar. A dilation results in similar objects. All right, very, very, very important. What qualifies similar? Well, a similar object needs to have the same angles. All right, the corresponding angles need to be the same, meaning that whatever the angle A was for A prime, it's going to be the same as the angle A. C prime would be the same as C, and B prime would be the same as B. The angles have to be the same, the corresponding angles have to be the same, and the side lengths are in proportion. In this case, they were all multiplied by 2, so they're in proportion to each other. We're going to talk a lot more about this tomorrow, but it's something to keep in mind. If you end up with, if you graphed a right triangle here, your scale factor of 2 would still have to result in a right triangle. It's still the same shape, it's just bigger. All right, so now let's go down to number 2. We're going to dilate by the fraction 1/3. So hopefully as soon as you see a fraction, you're thinking, okay, this is going to make my object smaller by 1/3. I'm taking 1/3 of it. But let's test it out and make sure that we're right. So again, our scale factor is 1/3. That's the number we're going to multiply by. Don't get your operations confused. A dilation is multiplication. 3 vertices means a triangle. So we're going to graph -3, 6 is A. -3, -6 is B. And then 6, 9 is C. Take your straight edge. Connect your dots. And then we're going to work on our image coordinates. I think it's a really good idea to show your work. It's not worth it to go too fast. So we have -3, +6, but we have to multiply it by 1/3. We did a lot with fractions to help prepare us for this. The most popular way to multiply fractions we know is top times top over bottom times bottom. You can put your numbers over 1, and then you can always cross simplify. Either way, you end up with the coordinate -1, 2. How did I get that? Because -1 times 1 is -1, and 2 times 1 is 2. Top times top over bottom times bottom. I'm kind of out of room, so I'm going to do some work down here. All right, if you can fit it on your paper, that's fine, but here's where I'm going to do my work for B. So B prime, my original coordinate was -3, -6. I have to multiply by 1/3. So I'm going to put my numbers over 1, and I'm going to cross simplify. 3 goes into 3 once, so we get a 1 and we get a -1. 3 goes into 6, 3 turns into a 1, -6 turns into a -2, and I get the coordinate -1, -2. So I'm going to clean this up a little bit. There's my coordinate for B prime. And now I'm going to work through and find my C. C was 6, 9. Only I have to multiply by a third. Put my whole numbers over 1. 3 turns into a 1. 6 turns into a 2. So that gives me a coordinate of top times top over bottom times bottom. 2 over 1 is just 2. I can cross simplify 3 and 9. 3 turns into a 1. 9 turns into a 3. Top times top over bottom times bottom. You get 3 over 1, which is just 3. I know fractions are a little bit more challenging than multiplying by a whole number, but we can all, easily multiply with the fractions as long as we show our work and go slow. It's a little bit easier to make it oops with fractions, so please be careful. So now here's our image coordinates, or our primes. So let's get graphing. We're going to start at the origin as always. We're going to walk to -1 and go up to 2. Because our scale factor is a fraction, we're making a smaller shape. We're copying, pasting the original ABC triangle, and then it's just like dragging the corner in to make it smaller. So it's a good sign that we're inside the triangle. B prime, walk to -1, fall to -2. There's B prime. And now C prime, we're going to start at the origin, walk to 2, climb up to 3. Take your straight edge. And we have our triangle. Before you move on, you've got to stop yourself and check it out. All right, could this be a shrunken version of the original ABC? Absolutely. All right, your vertices haven't changed at all. A's in the top left, C's in the top right, B's in the bottom. All right, your letters haven't changed. All that happened is if I was on a computer, I would have copy and pasted it and then shrunk this corner in to make this triangle smaller. It's a third the size of the original. My angles haven't changed. I still have an acute angle at C, and that needs to be the exact same acute angle as with C prime as it is with C. The angles can't change. The only thing that changed is the size of the side lengths. So they're not congruent to each other, but they are similar. So that's it for your dilation. We'll continue to practice in class as a group. But what you need to understand, the answer to those first 3 questions that we talked about at the beginning was that you multiply when you're talking about a dilation. That's what's going to make it bigger or smaller, is by multiplying the x and the y. If you're multiplying by a counting number, which is, it can't be 1 though. 1 is your multiplicative identity. So if you multiply by 1, you're going to get the exact same coordinates. So it's got to be anything bigger than the number 1. Or if you're multiplying by a fraction, it's going to make it smaller. If you have any questions, please let me know.